Hey everyone. Okay, so today we're going to talk about factor trees and exponential notation. Now, I'm pretty sure that most of you remember how to do factor trees. Okay, factor trees are a way to help us find out what the prime factorization of a number is. Okay, so if I take a number like, let me get my right tools here, 54. And I want to know the prime numbers that multiply together to equal 54. And you're probably thinking to yourself, well, who cares? Well, that actually helps us later on. When we know the prime factorization of numbers, it really helps us a lot when we're doing algebra. Okay, so I want to know the prime factorization of 54. Now, I'm going to use a factor tree to do that. I know that 9 times 6 is 54. Okay, so we're going to go ahead and write that down. Put our 9 here and our 6 here. Okay, now the next thing I need to do is I need to keep factoring these numbers in my factor tree until I get down to prime numbers. 9 is not prime, 6 is not prime, so I have to keep going. 9 is 3 times 3. 6 is going to be 3 times 2. Okay, so what this means is, well, the next step is we're going to circle our prime factors, all our prime numbers. Okay, here we go. 1, 2, 3 threes, and 1, 2. So what that means is that 2 times 3 times 3 times 3 is equal to 54. And like I said, that's actually going to really help us out later. Okay, now the key here was, let's see, we factored each step, circle your prime numbers. It's important we circle them because sometimes, like for this next example, they won't always be in a nice clean line like this. Okay, so let's do another example here. Now that one was kind of easy because we know from our multiplication tables that 9 times 6 is 54. Let's take a number that we might not know off the top of our heads. Let's do 432. Okay, 432. Now, this is where your divisibility rules handout is really going to help you. If you memorize those divisibility rules, you'll know, I mean, just looking at this number, it's divisible by 2 because it has a 2 in the ones place. It's divisible by 3 because if I add 4 plus 3 plus 2, that's 9. And 9 is divisible by 3. So this is divisible by 3. It's divisible by 4 because these two digits make 32, which is divisible by 4. And it's also divisible by 9 because 4 plus 3 plus 2 again is 9, and 9 is divisible by 9. So divisibility handout is really going to help you with this exercise. But let's just say that you forgot that and you don't know. The only thing you know is that 432 is going to be divisible by 2 because of this 2 right here. So let's go ahead and start factoring. 432 divided by 2 is going to be 2. Let's see, 2 goes into 3 one time. Okay, so I'll subtract my 2. 1, 2. 2 goes into 12 6 times. And there you go. It goes in evenly. 216 times. Okay, so 2 times 216 is going to give me 412. Now 216, again, you probably don't know how to factor 216, so let's go ahead and divide again. I know that I can get a 2 in here. Okay, and just keep repeating this process. 2 goes into 2 once, 2 goes into 1 0 times. 2 goes into 16 8 times. Okay, so that means that 2 times 108 is 216. Okay, great. Now that's what you have to do. You keep going through this until you get a number that you know from your multiplication tables. Now, 108 we know is going to be 9 times 12. That's in your multiplication tables. 9 is going to be 3 times 3, and 12 is going to be 3 times 4. Let's go ahead and get rid of this work here. And 4 is going to be 2 times 2. Okay, now here it's more important that we circle our prime factors. Here we could see them in a nice line. Here I actually have to circle them. So let's see, I've got 2, 2 is prime, 3 is prime, there's another 3 and another 1. All right, so we've got a bunch of 2s and 3s here. Let's see, I've got 1, 2, 3, 4 2s. So 2 times 2 times 2 times 2. And 1, 2, 3 3s times 3 times 3 times 3. So that means if I multiply all of those together, I'll get back to that number at the top of our tree, 432. Okay, and that's how you do the prime factors. That's how you do a factor tree for a very large number like that. Okay, the next step, and this is a good time to talk about it. I don't always want to write out, I mean, what if this had been 2 to the 10th? I don't want to write out 10 2s. We have a shorthand way of doing that. Okay, I can very easily write 2 times 2 times 2 times 2 in a very shorthand way using exponents. Okay, so that's going to be 2 to the 4th power. And just like that, 3 times 3 times 3 is going to be 3 to the 3rd power. Okay, so all of this right here, I wrote right in this little space. It saves a lot of time. So, by the way, this here, terrible arrow. That's awful. Try it again. There we go. Okay, this here is called standard notation. Okay, this here is called not the greatest arrow. Okay, but not as bad as that first one. Exponential notation. Okay, so if they ask for standard, you've got to put it in this form here with all your multiplication signs. And if they ask for exponential, you can go ahead and do it like this. And just so you can see, the exponential notation for this here is going to be 2, just 2 to the 1st, I don't need to put an exponent, times 3 to the 3rd. Okay, so standard exponential. All right, I hope that helps.